Howdy again and welcome back. This is going to be part 2 of the assessment, and we're probably going to get through another 2 pages here, just discussing more on functions, using this to correct on your test. So given the function below, which is a piecewise function, determine the requested values. So piecewise function exists in has multiple different expressions because we expect this graph to probably be represented by different lines over the course of time, and depending on our domains is when we're going to use certain functions. So here I'm trying to figure out, well, what is this function going to equal if x equals 0? So that means I'm going to use this equation because x is less than 3, this line because x is less than 3, and that's this equation. So this would be negative 0 minus 4, which just equals negative 4. And that is my answer to this. F of 3. F of 3 would be between these two values, but since the second equation if x is greater than or equal to 3, I'm going to use that one. So this becomes 3 squared minus 7, 9 minus 7, which is just 2. F of 20 is my final equation here. So this would be 120 divided by 20 plus 5. 120 divided by 20 is 6. 6 plus 5, just going to give me 11 here. This last equation was kind of one of the trickier questions on the assessment, mostly because it relied on this understanding that if f is going to map 120 somewhere, then f inverse is just going to map it back to 120. So these, because they're inverses, they can basically cancel one another out. So this question is the same as what is f of 120. So that is going to equal my last equation in that piecewise function because we are greater than or equal to 10. So f of 120 is just going to equal 6. 120 divided by 120 is 1. Plus 5, we end up getting 6. So was a little bit tricky, did require that understanding. Here we've got some transformations happening on functions, and we need to state what they are. So for this first one, we are adjusting the x value in particular with multiplying. So this is actually a b value, and if our b value is greater than 1, then this is a horizontal compression by 2. G of x off to the right, we're not directly changing that x value, we're adding on to the end result. So this is going to be moving our graph up 5 units. Here again, not changing the x value directly. We have an a value adjustment, and then this is, I believe I've got that referenced as our d value. So our a value is going to be a vertical stretch as it's greater than 1. So we're going to say a vertical stretch by 4, and then this d value is going to bring this graph down 1 unit. Here I am changing my x value with that takeaway 3. That's going to move it left or right. And because of that minus 3, that is going to end up moving it to the right 3 units. And the fact that our a value is negative, that is going to cause a reflection over the x-axis. Next page, we've got now kind of the opposite, where we're being told what's happening and we need to come up with the equations. And we can basically do these one at a time until we get down to our final equation. So if I just need to move something left by 5 units, then that amounts to adding on to the x value. If I need to reflect it over the x-axis, that means that my a value is negative. And then if I need to translate something down 4 units, then I'm going to take away 4. So this equation is my final answer to that problem. Translating left, happening directly on my x value here because I'm trying to move something left or right. So that if I add, it moves it left. So I'm looking at this. Reflect over the y axis means make my x value negative, the coefficient in front of x negative. Vertical stretch by 4 means my a value is going to be a 4, and then if I need to move this down 3 units, then I end up with this. So kind of take a look at it piece by piece as things are going down. Should have a pretty good understanding of what's happening. Reflecting over y-axis is going to mean making my x value negative, the coefficient in front of it negative, is going to reflect over the x-axis. Vertical compression by a 4th means kind of my end result, or outside of that absolute value, is going to have a 4th in there. Compression means that it's going to be in between 0 and 1, so we do want that fraction. And then if I'm moving this up 10 units, I'm going to add 10 onto the tail end of it. So you can use Desmos to kind of check on those and agree with them, but these are going to be the equations that we want for our final answers. So we've got this, and then we've got the circled equation above. If the point 2, 5 is translated to the right 5 units, reflected over the y-axis, and then translated down 4 units, what would the new coordinates be? So I would start, if we have just a basic graph here, so we have 2, 5. If I'm moving this to the right 5 units, then I know that 2, 5 is going to end up now being at 7, 5. So my x-coordinate is going to go up by 5. Reflected over the y-axis, so if I move a point from here over there, then the x-coordinate is going to switch from positive to negative. So now I've got this as I go down. And then if I'm translating something down 4 units, I'm going to be taking away from my y-coordinate. So that would just give me a 1 after I take 4 away from 5. Point A, B is transformed to A, negative B. So here I can see that my y value has changed from positive to negative. So as an example, that could be like 2, 1 switches to 2, negative 1. And if I graph that, I can see that this ends up being a reflection over x-axis. All right, so that is another 2 pages on the test. I'll be doing another video for part 3, and then we'll be all done.